All right, students, so I'm looking at this 6.1, 6.2 review worksheet that was due. It was Friday the 8th. Those are in the grade book. And I would say everyone pretty much consistently missed this question here, okay? Number 5, which is understandable. It is a difficult question, but we're going to go back and fix it. That's the goal. We need to make sure that we understand how to get the answer to this problem. All right, so I'm going to read the problem. It says typographical and spelling errors can be either non-word errors or word errors. A non-word error is not a real word, as when the is typed as TEH. A word error is a real word but not the right word, as when lose is typed as loose. When students are asked to write a 250-word essay without spell checking, the number of non-word errors X in a randomly selected essay has the following probability distribution. So there's that. The number of word errors Y has this probability distribution. So we have these here. Assume that they are independent. An English professor deducts 3 points from a student's essay score for each non-word error and 2 points for each word error. Find the mean and standard deviation for the total score deductions for a randomly selected essay. Show your work. Okay. So we are going to need a couple things, or to remember a couple things. Here was the PowerPoint that we looked at. This is transforming and combining random variables. So this problem actually has all of those. We have to transform the data and we have to combine the variables. So we're doing everything in this one problem, okay? What we have here are the counts, okay? And we expect there to be 2.1 non-word errors with this deviation. And then we expect there to be 1 word error and a deviation of 1 here, okay? We want to find the total deductions for this. The right ordering for this would be to transform these. We need to change these into their point values, right? What do we expect? How many points are going to get deducted for non-word errors? Well, it's 3 points each word. So if I go through here and I multiply all of these by 3, we have to transform it. Okay? That causes this to be multiplied by 3. So the new random variable would say 3x. We take the mean, we multiply it by 3. That gets us 6.3. Okay. We also do that to the standard deviation. Remember, multiplication affects all of these. So I'm going to say sigma of 3x equals, well, I got to multiply that by 3. Let me get a calculator to do 1.136 times 3. So I'll just round that up to 41. So 3.41. So that was sort of the first part of this. We're not going to combine these yet. We needed to transform them first. Next, we know that this is going to be 2 points for each word error. So we need to go through here and multiply this by 2 for each one of these. Okay, 2 for each one of those. That means these also multiply by 2. So we'll say mu of y times 2. I'll say 2y. So what is that going to be? Well, we just double it, so it's 2. What's sigma of y, or 2y? Well, that's going to be also 2. Okay, so now we're ready to combine these. We have the total point deductions for the word errors and the non-word errors. Now we want to combine them to find the total. So we had to do the transformation first. Now we're ready to combine them. So in our notes, when we combine random variables, this was the rule. So the sum of random variables, we can just add the means together to get that. All right, the mean of several random variables is the sum of their means. So we can just take these two means. So the mean of 3x, 3 times the random variable x plus 2 times the random variable y. Well, we just add them together. And that's 6.3 plus 2 is 8.3. And I think most people got this. I think the real issue was the standard deviation is what happened on this one. And I know my original video, I had a particular way I was doing it with the help video, the lesson. But if we take our time with it and do the transformation first, like what I've done here, it's going to make this a lot easier. So let's look at sigma formula. We're going to do sigma of 3x plus 2y. So let's go back to our formulas here. Let's go back to our notes. We have this formula, the variance, well, not the variance, we want the sum of random variables, the standard deviation. This is the formula we want. It's going to equal, so we'll go back here, square root of sigma, we'll say 3x squared plus sigma 2x squared. That's what we should be using here. So what is sigma of 3x? That's 3.41. So we'll write this in here. 3.41. We square that. Okay. We move over. Plus, we want sigma of 2 times, this is y. I put the wrong thing there. Y. Go down here. And we know that that's going to be this 2 here. So it's 2 squared. All right. So what does that give us? Well, let's grab the calculator. Square root. We want 3.41, square that, plus 2 squared. Okay. And then we get this as our standard deviation. So 3.95 is what we're going to put, which is the correct new standard deviation on this one. So hopefully that explanation clears that up. What I'm going to ask that you do with this is resubmit. Maybe you can just do number 5. Resubmit it. Send me an email saying that you fixed that and the other parts that I gave you feedback for, and I'll raise your grade on KITM. Now, I do need you to email me and communicate with me that you made those changes. I'm not going back. KITM doesn't do a very good job of notifying me when things get turned in. So if you want your points, make sure you email me and I'll go in there and check it. So we've corrected this one, but some of you have other problems that need correcting as well. If you need extra help on those, reach out to me individually. This was just one that was most commonly missed, and I wanted to go back and explain the problem.